Welcome to Integrations and Observations. My name is Ali Yousefi. In this edition, we'll cover Azure Application Insights, availability testing.
All right, so for this video, we're going to talk about availability testing with Azure Application Insights. I'll cover, what is App Insights, what's availability testing, different ways of constructing availability test. Definitely going to cover lots of demos from unit test to actually testing against what's called the Common Data Service API. We'll set up some Azure Monitor alerting, and we'll talk about some next steps on how to maybe kick off some CI/CD pipelines, maybe kick off some GitHub actions, etc., and maybe just talk about maybe some ways that you could further take action on the availability insights results.
On this slide, you'll find a quick reference to the various topics within this video. So why should you care about availability testing? Well, connectivity for sure. Practically everyone now uses some service in their daily lives, from, hailing a cab with Uber, from checking their email with Outlook, from even maybe running their smart thermostat. Everybody needs or uses at least some service. So making sure that it's up and it's available and it's responding is key. Dependability. We need those services to be responsive. We need them to something to help tell us when something's wrong, so we can continuously monitor and adjust and be proactive where we can. And that leads us into being actionable, right? The testing that we have can provide the insights that can provide actionable things we can do, such as kicking off some sort of automation to scale out, to notifying our IT leads and so on, to ensure that they're doing what they need to do to have a high SLA. So the Azure Application Insights feature is a pretty significant feature within the Azure cloud. It's native to most services that are within Azure. Can be extended to your own custom applications that reside in the cloud or on-prem, so it provides that hybrid connectivity. It can be used for availability testing like we're showing now. It can also be used for capturing exceptions, capturing page views to see your user adoption, capturing retention and churn, performance metrics, failure anomalies, etc. Again, it works with any service or infrastructure, and it can integrate with popular alerting systems such as Azure Monitor and automation systems, so Azure Logic apps for no or low code, Azure Functions, and even PowerShell using Azure Automation. So availability tests and Azure Application Insights come in two flavors, more or less: simple URL ping test and complex web test. So the simple ping test allows you to quickly ping your service, as it says, from around the world. You can choose which Azure data centers you want to ping from. This might be useful for pinging say a login page if you have a Power Apps portal, or maybe an Azure function to make sure it's up. If you need a little bit more complexity, like if you say want to run a flow, then you can look at a complex web test. These are specific scenario-based tests. One thing to note here is that the web test, the .web test file, and the whole web test kind of feature itself has been marked as deprecated. I think 2019 in Visual Studio is the last IDE version that will support it. So I would recommend here, where we start looking to the future and start working towards building our own custom availability test, which I'll show here in the next few slides. So I thought it'd be fun to kind of look at maybe some scenarios for availability testing before we actually go deep into the setup and demos and so on, for both URL ping test and custom test. Ping test, obviously, web pages, making sure they're responsive, and then what's the duration of the call, right? So if I, maybe I'm here in Texas and I want to see, how long does it take me, if I were to make a request to to a web page that was being served in Japan or served in Australia or something that's maybe a little bit further away than something here in the United States. I could ping it and then get that that duration back, as well as hey, was it successful, etc. Um, definitely services and APIs, make sure the uptime is there. So pinging it to get kind of a, maybe a heartbeat to it, see make sure it's up. What's interesting is, I mean, you may be able to use it for Azure functions, even if you think about keeping them up so that they are not having to, like if you're using the consumption plan, for instance, it might be an option there to ping it to see if it'll kind of prime itself and get ready to be ready for any request there. For Power Platform workloads, things like Power Apps portal pages work perfect, right? That's a essentially a just a web page. So you could test your various web pages from your home page to your login to your knowledge base support, forums, etc. Custom test, that's where you could get a little, you could, have more flexibility, have a little more fun there. You can, again, testing APIs, but not just, pinging an API to see if it's up, but maybe logging into the API or submitting for the CDS API, the Common Data Service API, who am I request to see, can I connect? Are my credentials valid? And then find out exactly, who am I? Get my response back, and as part of that, depending on how you set it up, you can collect other things like the any kind of headers. So if you wanted to get activity IDs, session IDs, API throttling limits, and so on. Login flows, right? It may be one thing to just say that a service is up, but can a user, log into it? So being able to log in again with maybe connecting through the API, but also maybe think about, actually having a UI test. So kicking off a test that simulates a user logging into a web page. So for a Power Apps portal, maybe it's not so much just making sure the login page is up, and maybe log in and then have them simulate a request to the IDP of your choice for Dynamics 365 workloads. Maybe we're looking at logging in, going through any sort of single sign-on page or any sort of again identity provider page you have. Log in, make sure that your app module is up and running. Finally, queries, you can, run queries and make sure that things are up. You can run queries on, DevOps pipelines, run queries on Azure services, run queries on, again, Dynamics workloads, or really any kind of thing you would like to query. And then once you get your response back, you can, again, submit the request that will show the next slide to Application Insights. Before we go into any demos, let's quickly talk about Azure Application Insights and how we would build availability test. The availability test within Application Insights can be used via the SDK or via the RESTful API. With the SDK, we have the .NET Framework and .NET Core versions we can leverage. If we go that route, we will create an instance of the telemetry clients and then use the availability telemetry data model that you see on this image here. For the HTTP request, you'll use a similar model, but you'll kind of have to build it yourself and submit it. So looking at this model here, we see a few properties that are of importance, including duration, which kind of tells us, how long did the request take to come back, and that can include just a single URL, or it can include the dependent resources. So think of images, CSS, subsequent calls, etc. That can all be kind of lumped into that, what we would consider one single request, parent-child, if you will. For the message, that will be, if it passed, typically the out of the box, like ping test says passed. So when building a custom test, to keep consistent with the URL ping test, I would suggest using the word passed, but you can leverage whatever you like there. For failure, in my experience, most responses will include some sort of HTTP response code. So that would be a 400, 500 level code. I would suggest adding that to the message with any sort of exception message or reason. If you get a 404 service unavailable, 500 internal server error, whatever it may be, including that can help us when we have to start troubleshooting our availability test. The name of the test is key. That's going to tell us, of course, which test we're running. And once we start looking at dispersing our test globally, the name is what will kind of group those tests together as a singular area of concern, if you will. So if we're looking at Microsoft services like Dynamics 365 availability testing, we may want to test a particular environment from across different data centers across the globe. We want to group those in with something that's kind of consistent. So you may say something like, Contoso production, availability testing. And then if you group it correctly, if once you expand it in the UI, you'll see the different areas that you've tested. And that goes right into run location. Run location is the property set on the availability telemetry contract to tell where the test was run. That can be hard-coded, as you can see in this image, or that could be pulled from whatever host you're running. So if you're running it from, say, an Azure function, like we'll show in later demos, running it in containers, or maybe even DevOps build agents, or even just running on local VMs, there should be ways for you to grab the location, either using geo with IP or maybe an environment variable of some sort. Success, think of like a Boolean. Hey, did my test, was it successful or not? So pass in, the true or false for that. For timestamp, just collect when you ran the test, so that when you do have to, troubleshoot or build some sort of reporting, you kind of know, okay, this is when the availability test ran. Again, make sure you add contextual information, so things like operational IDs to kind of keep these together, or session IDs, something so I can, group my particular set of tests together, and maybe have, that have that correlation, but maybe have independent IDs as well, like request IDs, which could be that ID field that we see here on this slide. So with that said, let's go into some demos. Okay, so in this demo, you can see I have a unit test called test availability feature test. Here I'm creating a operational ID, GUID, and running four methods that are called test availability telemetry, and passing in different URIs here. For each one of these, executing an HTTP request and then constructing a availability telemetry contract. And so this contract is the one that Application Insights relies on to showcase the custom test that you'll have set up within your Azure function, or your whatever host, whatever way you're running the test. You can see here I'm setting the duration to the duration that's returned from my my response on my request here. I'm adding a request ID for the ID. The message, if it's passed, I'm going to try to stick to a similar type message that the URL ping test has. If it fails, try to write the status code if it's a 403, 404, 500, whatever it may be, and as well as the reason phrase. The name of the test will dictate how it's kind of grouped together inside of the availability feature. Write your success. In my case, I'm getting a success status code from the HTTP response message, then adding a timestamp. As you can see, I'm also adding some contextual information, and then using the track availability call here. Okay, so we ran our availability test here. I'm actually in the availability feature within Application Insights. You can see, some other ones I've ran some ping tests here, but we can see that the availability test that I've run from my unit test actually shows up. And what's neat about it is that I see this custom piece here, and I can see each one, the way I've named them, you can see the availability test of, say, Bing, Google, Microsoft, Yahoo, and how it's looked over the past 20 minutes. So for Bing, I can see that that shows that, and so on. So I can drill into that. Now, if we actually go look at the logs here, we can see that I have my availability test. I have my message. In this case, it wasn't successful, showing forbidden. Yahoo is passed. Bing was passed. Google and Microsoft forbidden. And I can get the duration. If I don't set the location, the IP address that I'm running it from will actually be used to find my city and state, which is helpful if you don't want to hard code anything. So in this case, it's going to find where I'm running this from in Fresno here. And yeah, that's showing how we can start collecting both success and failures, and how that started from the unit test and now is in App Insights. All right, well, in the previous demos, we showed, how to construct a unit test to get started with availability testing. We showed how to run it from your local device and push events to Azure Application Insights. Reviewed the availability tool, showing how, by not setting the location, it can automatically use the IP address from your local device. That said, once you start looking towards deploying it to maybe run it in the cloud, run it on a cloud or server, for instance, you may want to think about some of the considerations that come into, running it on that particular host. Running it on a, server that you control, or a server on Azure, or a hybrid approach, Azure Application Insights, by not setting that run location, would still be able to figure out, your location by the IP address that's being served. That said, it's important to call out that the IP addresses, or at least the IP address location mechanism, won't always be the case, by if we're running, say, in a container or service fabric or something. So I'll show you later, some techniques on how you can, grab the location or set the location, so that you can still be able to report on where your test ran. But before we get into that, it's important to start thinking about high uptime, right? So the host that's going to host your test needs to be available. You can't run availability test without having the host be available as well. So if you're going to, run these locally on your machine, well, they're only going to run when your machine's up or you're kicking them off. Same thing if you're running it on a local server, VM server, it has to be up. That's where, the cloud can come into play by hosting, on Azure or another compete cloud. You can now kind of maybe have a higher availability there. So that's key when you're building your test. And that also is important to call out, that when hosting a test, think about having that replication across data centers and even across geos, right? Just in case of any sort of localized event or disaster, right? You can have a kind of a replica that's maybe nearby, or you could have a replica that's clear across the globe to some other point. So make sure you consider your availability when hosting. So flexibility is another one. That's going to be key when you're kind of creating your test. Build them so that they're simple, and like we see there, this simplicity is key for keeping your dependencies minimal. You want to make sure that your test is not doing too much. We don't want any sort of blocker, single point of failure. We want to be able to make sure our test is doing the minimal as possible to just tell us something's available. Because if it again relies on something that's unavailable, well, then we're maybe in a spot where we're not really recording accurate results about the workload or service that we're trying to report on that's available. So remember, keep it simple. For flexibility, you want to think about making it modular, making it be able to run on various workloads. So if I say I want an availability test that can run Windows, run Linux, run wherever, however, think about how you could build a test or use a service like Azure Application Insights that would allow me that flexibility. And why we like App Insights is it provides an SDK, which is great if you're on on Windows workloads or .NET Core if you like working in .NET. But it has the HTTP endpoint. So if you're talking, PowerShell, you're talking about anything that can kick off an HTTP request. I can, for my, Raspberry Pi, for instance, I could kick off an availability test and tell you, hey, my Raspberry Pi that measures the humidity in one of my, rooms, for instance, it could tell me that it's available, right? Um, so yeah, think about flexibility. Think about how a test could be run independently, or it could be kind of plug and play into a bigger process. So maybe, as part of a orchestration you have with Azure Logic Apps, you maybe first want to ensure that something's up and running before you submit it. So maybe you need to have this quick test and this report on the availability before you submit your message. So, having the independent call, but thinking of it as a way of making it modular so that it can be, kind of plugged in and used as part of a bigger process. Some options at the bottom I think are helpful are Azure Service Fabric. Obviously, that lends you to like Azure Functions. Continuous integration agents, so Azure DevOps, GitHub Actions, and then containers. So continuous integration agents, helpful because you can kick off tests from pipelines, from CI pipelines. Both GitHub Actions and Azure DevOps allow triggers to kick off pipelines or workflows, as GitHub would call it, where you could kick off your tests and then report to Azure Application Insights. For containers, what'll be neat for those is that they provide you a kind of static hosting environment, which I'll touch on a little bit later. All right, so for this demo, we're going to kind of extend what we showed earlier with the unit test, and we're going to actually implement a availability test for the common data service. So what you see here is a Azure function inside of Visual Studio. The Azure function here, you can see I have a function name called test availability that uses an HTTP trigger here, and we can post to it. I'm adding in the execution context. That's just kind of a practice I use to be able to collect the invocation ID. But you see here, this is the sample code that's generated by uh, the Visual Studio template. So you'll see some basic things here like this log information and so on. I'm not really going to be using this, but it's there. Here's key. All I'm doing here is I'm connecting to Dynamics. I'm using the web API. I'm foregoing using the SDK. I wanted something going back to our, point about simplicity. You know, I like to reduce dependencies on SDKs and so on. So I just want something that I can quickly just send a request and get a response back and not have to worry about am I using the wrong version of an SDK and so on. So in this case here, connecting to Dynamics, passing in our tenant ID for our authority, client ID, client secret to actually get our auth token back, our JWT token, and the org URL. So we'll construct a call to get the token. Once we get the token here, I'm using a stopwatch object, and I will be submitting what's called a who am I request to the CDS API. That's going to take the token, and it's going to tell me who my system user ID is, so who the actual user I am is, what's my business unit, things like that. And then I'm going to do a stop here. Optionally, you could maybe grab a couple of more information, so like organization information if you want to grab, what's the org ID, or hey, maybe what's the build version. So maybe you want to kind of start tracking when there's been an update to the app itself. To maybe kick off something downstream. We talked about like plug and play. Well, these availability tests could also be used to kind of maybe, push updates to kick off say maybe a regression testing you have set up based on an update that was pushed from like a service update that was pushed from Microsoft here. So you could add that if you want. In this case, I'm just doing a stopwatch start stop, and then I'll be sending availability telemetry. Let's go look at this method for a second. So inside of here, you can see I have the availability telemetry contract. the same kind of stuff we talked about before from our unit test. A little bit different here. I'm actually going to grab the headers from my response from CDS and add them to the custom dimensions or property bag. You'll see I have the key and then the value here. This is important if you're running within an app service, so web apps, Azure Function, etc. There's an environment variable called region name. You'll want to use this because if you just kept run location empty, it actually won't, populate with this. But setting this region name variable will say, like what data center you're running on. So South Central US, um, East US, West US, etc. So I'll show that a little bit later. But yeah, use this environment.get environment variable parameter here. Timestamp, operational ID, send your track availability, and then do the flush to send the sync call. And that is the HTTP request. And here we see the another one I've built, which is a timer. Right, we talked about having HTTP for ad hoc, as I just showed. Well, we have a timer trigger as well. You can find a quick search, find how to build out the cron expressions here, but this one's going to run every 10 minutes. And again, run a who am I. So this one, when we set it up in Azure Functions or deploy it to Azure Functions, it will set it up to run every 10 minutes. Speaking of deployment, what's neat about Visual Studio is that you can quickly click on deploy or publish, excuse me. And when you publish, you can build out various publish profiles for your data center. So maybe you want to deploy a specific version to a data center. Maybe you need to make a change and you can deploy them all out. You can use publish here. You can use publish with the with PowerShell as well, either using like Azure, PowerShell commandlets or what have you to publish. When you publish, keep in mind like what I'm doing is I'm using app settings, application settings for my configuration. You could use Key Vault. Again, I wanted to keep um, my potential points of failure minimal, so I'm just using app settings. So once you deploy it, you need to go make sure your app settings are created. If you say, have to regen your keys, make sure you go update those and so on. So that once you build it, once you publish it, you'll have your test up in the cloud. So let's go see what they look like once they're running. Alrighty, well, we have deployed our Azure function that we showed on the previous demo out um, to the cloud. I've deployed it actually to multiple data centers, and it's been running for at least a day now. You can see I'm already collecting. Overall, we're looking at 100% uptime, so that's great. You can see here in the availability feature, I can do things like scatter plots and lines, which, what's neat about the availability is that, I mean, I could see the 100% one, which is fine, but the scatter plot can also show me like durations and so on. So maybe I see here, it seems like there's a little bit of it's kind of skewed. So I could go see, at South Central US, this one said at Friday the 16th, that it looked like it was taking 8.7 seconds, which is a little bit out of the norm. This was 3.6 in West Europe and South India. So here's what's fun about it, is that I deployed that same code that's running on that's running in the Azure function on timer trigger. I'm not going to really show that, but if you work with Azure functions, you can kind of see how that would work. By using that environment variable, I can now, and using the same name, so an availability contract, having that name and setting that environment variable for a run location now allows me to group these by the various data centers they're running on. So I can see South Central US provides me 585 milliseconds to do my who am I call. West Europe, 888, South India, 1.04 seconds. If I want to choose, say, South India, I can get a nice little scatter plot of certain times, 2.7 here, 2.10, but we can kind of see it falls in between this, you know, 1.5, 500, 1.5 kind of thing. If I go here to South Central, very short ones, 204, 204, and then we have some of these that skew. So that's where you can also kind of like, if you want to start looking at percentiles and say, okay, give me the, you know, 75 percentile, 95 percentile, and try to get some of these outliers out and see like what the kind of what the norm would be here. So you could do that, and then if you wanted to drill into these successful ones, you can run this, run your end-to-end transaction detail. There's not too much going on here. What's neat about this is that since I'm collecting the custom properties, I could see, maybe the availability test, there could have been some issues because of the remaining XRM request or time remaining. This is for CDS API exclusively, but maybe you're running another API that has some sort of throttling or something that you could kind of look at these properties and see what was going on here. So that's using the end-to-end. If I want to, I can quickly, and if there's an issue, I can create a work item and have it integrated with Azure DevOps. But if I go to my logs here, you can see inside of availability results, this is kind of key. So it shows our scatter plot. We can see the results here, average duration, blah, blah, blah. If you just want to see, let's go just take a look at what's going on here. So I'm going to just run a quick query and see on all my availability results, West Europe, so on. So I could see, this is kind of what it shows here, my custom dimensions. So I could see 530. So if I have one running at 530, 530 1 second, 530 1 second. And so all of these are using the same. What's interesting is this custom dimensions. I can see that my rate limit here, my XRM request rate limit, I see 5999. If I go to the one right above it, what do we think this would be? 5998. And just finish that one off. 5997. So what we're showing here is, not only the availability, but because we're collecting the headers from our SPN user, or application user, we can actually kind of see what the remaining requests are at any time. So maybe you could even use these availability tests as well to report on some other metrics. Again, like I said, the API throttling, the organization, um, build version, etc. All right, some considerations for testing, and then kind of looking ahead. Um, when you're building your test in Azure Application Insights, you want to make sure, I think, that having both, timer tests are great, right? So you can kind of have that set it and forget it and be notified when something's happening, which we'll talk about next. But have that kind of, reoccurring test that'll happen every so often. I think the cron-based jobs make a lot of sense. When you're building them, if you're using like Azure Function, for instance, make sure that you try to make that schedule, somewhat, flexible, modifiable without having to, maybe redeploy your code. Um, that said, I think it's important to also have a direct ability to have a direct call to a test. So being able to run an ad hoc test. I think the HTTP trigger works well here. That would allow us to, submit a request. If we wanted to run it, say from Postman, run a request from, Power Automate or Logic App workloads, uh, anything we really wanted. But that the HTTP request trigger allows us to have both the timer trigger allows us to have the reoccurring, the HTTP allows us to have the ad hoc testing. Well, that would, cover the testing piece, but now we start looking at, once we're testing and we, are starting to collect, what can we do when availability is reduced, and what actions can you take? We're going to talk next about something, with Azure Monitor that will help us with the actionable insights. But we want to think about, when availability is reduced, what can we take? What actions can we take? And then how can I find out what caused the downtime? Ultimately, we want to find that RCA, that root cause analysis of the availability, to determine if it's something that maybe the underlying service that we're relying on is failing, the infrastructure is failing. Maybe it's something that was deployed is causing outages and causing downtime. So, being able to take, what's reported from the availability test and correlate that to tracing, to exceptions, et cetera, to kind of find where the cause may be from. All right, we've got our availability test pushing events to the availability results table within Azure Application Insights. At this point, we'll want to look at crafting our queries, making sure that we're finding the data points that we are interested in, and then once we find those, how to tune those queries to provide us actual meaningful data. So we want to think about our availability tests at some of the events. We want to be able to capture everything, but I think it's important to keep in mind that there could be some non-successful responses due to like transient error, due to potential throttling, something like that. So, understanding maybe if there's anything we could take away, like initial takeaways from our events, and maybe filter some of those out to make sure that we're being notified on actual um, downtime events. And Azure Monitor alerts will help us with that. We could start with our queries. We could start, crafting those. It can provide us some suggestions on how to tune these. And so building those alerts, I think if you start with a query, you'll start getting notified. Maybe you'll get notified too much, and that will help you know how to kind of scale back or tune your query, if you will, to make sure it's only notifying you when needed. Some of the cool features of Azure Monitor is it allows you to kind of work in two areas to work in notifications. So if I set up notifications, say I set a particular threshold, I say, well, maybe a single data center is failing, but I really want to just be notified when more than one or a specific data center is failing. Maybe I have a data center I know is a little flaky, so I'm gonna, maybe say, all right, if that one's producing some errors, that's understandable. But I have another data center which is serving the vast majority of my user base. That one needs to be, up as much as possible. So I'm gonna, want to be notified when something happens. So Azure Monitor can query and find out which particular data center in that scenario, is failing, and say we find the one that's of importance to us. We can run queries against it, find out if it's down. If so, set up some notifications. Notifications can be, telephone calls, right? So you could set up a Teams bridge. You could set up, calls to your mobile device. You could set up chat. So you could run with the Azure Communication Services. You could set up a, a chat kind of bridge to be used. You could kind of simulate a bot telling you that there's some issues here. You could set up toast notifications. I mean, we're all connected now with mobile devices, so being able to use push notifications to send pop-ups to your mobile device is key. And then again, et cetera, like email, et cetera, can be used. So distribution lists, DGs, that kind of thing. That would cover notifications, but the really cool piece would be the automation. So, you know, taking taking that event, going back to like the downed data center call, maybe we say, okay, well, maybe we need to move our workload from that data center to another one, or reestablish some endpoints, something like this, to make sure we had that redundancy. So with automation, we can kick off webhooks. We can kick off Azure Functions, Azure Logic Apps, all natively. So think about that. If I got this downed, data center, this downed endpoint, I could then kick off a Logic app and build it in a way where I could say redeploy. Say this was I don't know, an Azure function that works as an intermediary between common data service and one of your downstream services. Maybe for whatever reason that Azure function's not responding, the data center's down, maybe it's getting patched, I don't know what it is, but imagine you could kick off a Logic app that could maybe reconfigure where your CDS webhook is sending traffic to. So if you had, say, like an east-west data center type approach, you could go from the say the failing west data center to the east, reconfigure it, and have it flow, like reconfigure the flow of the messages. You could redeploy altogether, something like, for instance, if maybe there was a deployment that failed or caused an issue, you could, maybe redeploy from a previous commit or a previous package. So having that automation piece is really gonna help us. I forgot to mention, PowerShell is also a play. So Azure Automation, you can run, commandlets, etc., to again to do anything from, again, notifying or automating something. It's key to point out that each Azure Monitor alert can can have both flavors, can have notifications and automations. Um, each alert can have severity levels. So depending on maybe what data center it is, you could say, well, this one over here that's a little flaky, I may say this is a Sev 3, but this one here that my user base relies on needs to have high uptime. This could be a Sev 0, Sev 1 type case, which can, maybe send notifications to specific teams or kick off particular automation. All right, so finally in this demo, we're going to take some of the availability results that we're collecting. We're going to build out some alerting for us. So I've already went ahead and clicked from creating a query that we saw earlier. There's a button at the top of the log analytics kind of explorer piece that allows you to quickly create an alert role. So if you click on that, you should see something like this. Um, you'll get into the search query piece here, which is the condition. In the query, you could you could create your own query, use the one that's from there. In this case, I'm showing availability results where my location is the South Central Data Center. Um, all mine are 100%, but you could say like where false or where true, kind of shorthand for success or not. If you did where false, you could set that up, say, how many number of results? Well, maybe I need this to be, if there's any more than 0, this is a very important data center to me, and I want to evaluate over the last hour, um, and then so on. And then when you're done, you'll set the frequency as well, like how often to run the query. So you can say done, and you can see here estimated cost because of the amount of times I'm going to be running it. Um, then you get into action groups, and you can set up certain things for emailing, right? Or you can, like for instance, if I want to create an action group here, I could set up, notify and say notification type. I can email the ARM role here, or excuse me, Azure Resource Manager role, or do like we talked about, email, SMS. So SMS, Azure Push, voice, email. This would be interesting to see how you could connect it to the Azure Communication Services here. So you could set that up, and you could say, I want TOSO support at toso.com, and say, okay, great, and that's fine. We'll create that one. Well, if you get it right, you just give it a name, notify, and hit review, create, and hit create. And it's pretty quick there. It'll create the action group for us. And then we can actually create another one, like I mentioned. You can have multiples here, and you can choose, do I want an action? Runbooks, Azure Automation. So that's PowerShell. Azure Function, I can quickly connect to a function and look, like I could say track an exception here. So I could use my Azure Function. I want to even kick it back, or I can kick off some sort of integration, or like I said, redundancy pattern. Azure Logic App, you can again kick off quick logic apps as well. Let's see, what else do we have here? Secure webhooks and webhooks. So webhooks, you could connect to a third-party integration. You connect to a Power Automate Flow, something like that. So you could set all these up. We'll just quickly say something like my function here, and just say track an exception. Hit OK, and we'll say track exception. And hit review and create basics. It needs a action group name, track exception. and hit review and create, and that again should go pretty quick. Go back. You could set up alert rules, so you could say track the South Central US data center, check your severity. Well, this is a big one for me, so I'm going to call it a sub-0. And then you can enable and suppress alerts here. So by quickly setting this, I can now have an alert rule that will now alert me when maybe my availability tests are not successful or don't meet a certain threshold. All right, start wrapping things up. We'll talk about looking ahead. So now we've implemented App Insights availability tests. We've deployed it to the cloud. We started collecting from multiple data centers, and we've created Azure Monitor alerts for reactive and proactive um, alerts. So looking ahead, think about how, we're showing a demo for the CDS API. Think about how, and this could work for any API, but think about not only API availability test, but UI availability test. Just because an API is up doesn't mean that a UI is responsive. Again, with a UI, there's multiple, integrations or services that are employed when doing something simple, maybe it's logging in, where you may have um, Active Directory, Azure AD, for instance, may come into play there. So also testing the UI to make sure it's responsive. Can I actually provide my credentials and log in and pull up something? So an example would be, think about connecting to an app module for Dynamics 365. So just going to that as a user, I would have to open up a browser, log in, and then click on an app module, for instance. So we're looking at, dependencies on browser versioning. Is the browser I'm using supported? Dependency on Azure AD for login. So if there's any issue with that, then we would, not be able to log in. And then finally, making sure I have the security, I have the authentication through Azure AD, but the authorization to do what I need to do to access the app module. So all of that could be considered quote unquote availability as well, to make sure that, this is available to this user or particular set of users. Stable and consistent test environments. We talked about different browser versions, talking about different dependencies we may have for our services. Being able to test on a stable environment could be like, okay, I'm running a particular version of a tagged version of a container that has a subset of services and products and so on that are living on it. So certain versions of .NET Framework, certain versions of Node.js or anything like that. So being able to quickly test on certain configurations of environments is going to be key. And Azure Functions actually allows you to both deploy to particular runtime stacks that are running on Service Fabric, but also bring your own container, which I think is going to be key there to have a consistent test environment. Continuous integration and deployment. So, as we're, finding maybe our availability has gone down, we can figure out, maybe there was an issue due to a recent code push or change. Part of the automation piece that we talked about, you could kick off a build pipeline to maybe either revert any de deployment that had just gone out, or quickly notify someone to update the code to get out a new deployment. So think about how you could use your availability test as part of a kind of a trigger for continuous integration and deployment. Well, that concludes this video. Thank you so much for watching. You can find my contact information in the bottom right-hand corner. Feel free to reach out with any questions or comments you have. Thank you.